Welcome to This Explainer. Today, Dr. Christophe DeLong and Connexa Formation present something that is going to completely flip your understanding of human biomechanics. We literally take our most complex biological tools for granted every single day. But I promise you, by the end of this, you are never going to look at your own hands the same way again.
So let's just go ahead and shatter the traditional idea of the hand as this simple mechanical tool. When we actually look at the research, the hand isn't just taking orders from afar. It's the executrix of our will. It's the visible, physical extension of our brain's cortex. I mean, it represents nearly a third of our motor and sensory brain mapping. That is absolutely wild.
We're going to deconstruct the hand across 5 key areas today. First, the executrix of the will. Second, the visible brain. Third, wear and pathomechanics. Fourth, the duality of artisan versus artist. And finally, Connexa's actionable grammar of movement.
All right, let's jump right into Section 1, the executrix of the will.
Think about this. If the hip is our body's heavy-duty motor, the hand is the ultimate, precise executor. It relies on an incredibly complex architecture of 27 bones. Evolution made such a fascinating choice here, right? It deliberately sacrificed brute, solid strength in favor of infinite combinatorics and micro-precision. With over 20 joints working in total synergy, an expert like a surgeon or a master watchmaker can achieve a manipulation precision of just 0.5 millimeter.
And this comparison brilliantly illustrates the contrast between our primary interaction points. The foot is built like a massive vault. It's designed to react to the ground and absorb up to 8 times our body weight. But the hand, totally different ballgame. It uses these delicate modular arches to intentionally explore and transform the world around us. Basically, the foot supports our reality, but the hand alters it.
Okay, moving on to Section 2, the visible brain. Let's get into the software of this whole system. The brain doesn't just command individual muscles like it's pulling strings on a puppet. Instead, it manages these massive, complex grip schemas and pressure gradients over a huge area of the cortex. Essentially, the brain speaks to the hand in full, complex sentences, not just individual letters.
So the absolutely crucial point here is understanding this concept called gnosis. Basically, this is the hand's ability to act as a high-tech sensor array. It can recognize an object in total darkness. Saturated with these high-frequency receptors, the hand reads the physical world and shoots that data back to the brain instantaneously.
But you have to clearly separate gnosis from praxis, which is the intentional output. And this distinction is vital in clinical diagnostics. Why? Because a patient's hand can actually be physically strong, but if they are neurologically agnostic, meaning they just can't process the sensory feedback, it leads to this really baffling clumsiness. They might drop their coffee cup, not because they're physically weak, but because they quite literally didn't realize they weren't holding it properly.
And this is where it gets literally mind-bending. The brain uses something called feed-forward anticipation. It actually sends signals to pre-adjust your hand's opening span and calibrates the exact grip force required before you even make physical contact with an object. Your hand actually prepares to feel a specific texture before it touches it. You know when you pick something up expecting it to be heavy and it's actually super light and your hand kind of jerks? That neurological shock is exactly what we're talking about here.
Which brings us to Section 3, wear and pathomechanics.
So what exactly happens when this beautiful, intricate system breaks down over time? Well, we see profound impacts on our daily autonomy. Take carpal tunnel syndrome. Think of this not just as wrist pain, but as a neurological freeze. The pressure in that narrow tunnel literally severs the rich communication between the brain and the hand. Or look at rise arthrosis, which wears down the thumb's dynamic pivot, essentially robbing us of our ability to oppose our fingers and manipulate things. Now you might be wondering, what's the very first sign of this breakdown? You'd probably guess a weak grip, right? Actually, scratch that. It's not. It's the loss of full extension. Long before the pain even starts, the inability to fully open and flatten your hand distorts the entire mechanical chain. It completely throws off that delicate balance between the muscles that grip and the muscles that release.
Okay, let's dive into Section 4, the artisan versus the artist.
Beyond just pure, everyday utility, the hand possesses this really profound duality. When we map this out, we see a fascinating difference. The artisan relies on short neurological feedback loops. They're adjusting force instantly to master physical resistance and just make a tool work. But the artist, they use long feedback loops to dialogue with the imaginary, prioritizing emotion, symbolism, and spatial awareness. Think about the artisan paradigm for a second.
The artisan's hand is the ultimate executor of function. It is expertly adjusting force to manipulate heavy, stubborn materials like wood, iron, or even just turning a steering wheel. It's all about mastering the physical world to ensure longevity and utility. On the flip side, we have the artist, or the choreographer. They use the hand to literally sculpt the air. It's a massive shift. The objective here is pure emotional expression. A master artist's hand has eliminated all that parasitic tension, and it moves with a grace that is, for all intents and purposes, perfect mechanical economy.
And that leads us perfectly into our final segment, Section 5, Connexa and the Grammar of Gesture. So the big question, how do we take all of this rich, complex data and actually make it actionable in a clinic? Well, the Connexa tool is a real game changer here. It doesn't just measure raw, brute grip strength like old-school tools. It evaluates the precise temporal grammar and fluidity of the hand through advanced video analysis. It treats human movement like a spoken language, looking for the exact syntax of a healthy gesture. They look at what Connexa calls the canonical gesture sequence. This sequence always flows in a specific order, from opening to orientation, pre-activation, contact, and finally, pressure adjustment. And here's the genius part. By watching this AI can detect anomalies. If any single step is inverted, delayed, or blended together, which happens when a patient is struggling, it immediately flags a pathology way before a standard physical exam would ever catch it. And you're going to love this. It does this using just a standard smartphone camera running at 60 frames per second. The Connexa AI evaluates highly specific visual criteria. We're talking about identifying microtremors, asymmetrical openings, and interdigital timing delays down to like 20 or 40 milliseconds. These are tiny micro-hesitations that the naked human eye would completely miss, but the algorithm catches them instantly. The true brilliance of the whole system is how it translates these physical, fluid gestures into structured data code. This allows for rapid machine learning comparisons against healthy baselines. Most importantly, it allows for crucial longitudinal tracking of a patient's neural capital over time. We can finally, objectively, measure the decline or the recovery of that vital brain-hand connection.
So as we embrace these cutting-edge Connexa diagnostics, it really leaves us pondering a vital question. In a world where screens and automation are rapidly replacing the rich, tactile feedback our hands evolved over millions of years to process, how do we preserve our most human connection to the physical world? Because at the end of the day, as this final thought reminds us, a strong hand simply resists the world. A fast hand survives it. But only a free and conscious hand, one that is neurologically sound and intentionally directed, truly creates. Thank you so much for joining me for this explainer on the hand's visible brain. Catch you next time.